All right, guys, today we're going to be talking about completing the square, how to solve quadratics by completing the square. Okay, so completing the square, this process involves creating a perfect square trinomial, which is then factored as a perfect square. So we get that nice quantity squared like we saw with our solving in square roots method. And then we finish solving with square roots. Okay, but first we have to make this perfect square. So how do we do that? Let's first look at some of the positives and negatives of this method. Positive is it works for all quadratics that have all three terms. That's beautiful. So any of them, even those tough factorable ones, we can solve with this method. The downside is it can involve lots of fraction work. So we'll see as one of our negatives. Okay, another positive though is it is used to find important parts of all conic sections. So parabolas, circles, ellipses, hyperbolas. If you want to know why it's called conic sections, you can look that up, but that's not part of our lesson today. Another positive is this is where the quadratic formula comes from, is this process using ax squared plus bx plus c equals 0 and doing all of the steps we're going to learn today. Okay, the downside is this is or can be one of the slowest methods. Quadratic formula and or completing the square are probably the two slowest methods. Sometimes one's better than the other. It just depends on some of our cases. Okay, so let's look at some of the steps that we're going to have to do, and there's quite a bit here. So if you need to, you can pause the video and write the notes down now, or wait till we go through the first example. I would say probably wait till we do the first example here, which I did have to call example 0 because I messed up my numbers, but I didn't want to have to change every single other one. So this is example 0, and we're going to do this as we follow our steps. Okay, so if I have a quadratic in this form, where it's set equal to 0, first thing we do is divide all terms by a if necessary. So as you might notice here, my a value is 1. So dividing everything by 1, probably not necessary. Okay, so no need for that. Step 2 is move the constant c to the opposite side if necessary. So in this case, we're going to move our 4 to the other side by subtracting 4. And as our sub-step here, we're going to set up plus blank on each side. Okay, so in other words, where that 4 was, we're going to put plus blank. And over here I have negative 4 plus blank. All right, what we need to do is make this side factor as something that's a perfect square, like something times itself twice. So to do that, we need to find half of b, so now we're over here using this formula, half of b, half of the middle term, squared. Now, sometimes when we're working with fractions, if b is a fraction, you can think of it as this way, 1/2 times b, or b divided by 2, half of b quantity squared. Either way, this is better when b is a fraction. This is better when b is not a fraction. Okay, so here's our b value, negative 6. So let's find half of its value. So we're just going to divide it by 2 and square it. Okay, well, half of negative 6, of course, is negative 3. And negative 3 squared is positive 9. By the way, you should always be getting a positive value, because it doesn't matter if this number in here is positive or negative. Times itself twice will always give us a positive answer. It's actually why we also always set up plus on each side, because it will always be a positive number. Okay, so this is the value we need to add on each side so that this side factors as a perfect square. Okay, so if we were factoring this the long way, and I'll show you a way that makes it a little bit shorter, the two numbers that multiply to positive 9 and add up to negative 6 are negative 3 and negative 3. So x minus 3 and x minus 3. Okay, on this side, we can combine these two terms. Negative 4 and 9 make 5. And notice, now normally we wouldn't even write this step quite this way, at least on the left side. Notice we got the same thing times itself twice. We've made something that's a perfect square. Okay, and that's actually step 4 here, is factor it as a perfect square. And this is giving us a little bit of a hint that it always ends up being x plus or minus whatever half of b was, quantity squared. So in other words, when we did half of negative 6 and got negative 3, that's the value that ends up in our perfect square. Okay. So this thing equals 5. And we saw this last time with some of our square roots, and we can finish solving this now with square roots. We're going to square root both sides, and don't forget of course, sorry, to put our plus or minus. So we're going to have, oops, let me change colors, x minus 3 equals plus or minus the square root of 5. And our last step is to move that 3 to the other side. So if we add 3 over, remember, once we've set up plus or minus, this needs to stay in front of the plus or minus. So when we go to write our final answer here, we should have x equals positive 3 plus and minus the square root of 5. So remember that really there's two solutions here, and if we needed their decimal values, it'd be 3 plus the square root of 5 and 3 minus the square root of 5. This is just the nice compact way of writing both of those solutions at the same time. And for those of you that have done quadratic formula before, which should be all of you from Algebra 1, you might notice that you get answers kind of like this when you use quadratic formula. Exciting. All right, so let's practice the same thing. I know all the steps aren't sitting right here on screen like they were for us before, but that's all right. Let's follow through our steps. I'll verbally go over them. So the first thing, if I have my quadratic set equal to 0, which technically it doesn't have to be because our first step is we move our constant, well, I'm getting ahead of myself. Our first step is we divide everything by a if necessary, which is not necessary. The second thing we can do is move our constant to the other side. Okay, so it doesn't have to be set equal to 0. If the constant is already on the other side, then great, they saved us a step, right? But now we'd have x squared minus 4x plus blank, this is pretty far away, equals negative 6 plus blank. Okay, now remember, to create our perfect square, we need to take half of b. So half of negative 4, so this is kind of side work, just doing it underneath, and square it. Well, of course, half of negative 4 is negative 2, and when I square that, we get positive 4. So to create a perfect square, something that will factor as times itself twice, we need to add 4 to both sides of our equation. Again, we're doing this to keep our equation balanced, right? If you add 4 on one side, you have to do that to the other. So now we can factor the quadratic on this side. The two numbers that multiply to 4 and add up to negative 4 are negative 2 and negative 2. Okay, which would factor as x minus 2 quantity squared. And that's what we're really after. This thing that's a quantity squared, so we can use square roots in the end here. Simplifying the right-hand side, coming back to these two, adding them together, we get negative 2. So thinking ahead a little bit now that we're about to go use our square roots, I think we're going to get some imaginary or complex answers here. But we can get rid of our square by square rooting both sides. So here the radical gets rid of our square. X minus 2 gets to come out of there. And we get plus or minus. And if we want, we can go ahead and simplify this. It's not a whole lot to it. Just take out an I, right, for the square root of negative 1. So I root 2. And our last step here is going to be to add 2 over. And our final answer should be x equals positive 2 plus or minus I times the square root of 2. All right, our next one over here in the top. All right, it's already set equal to 0. We don't need to divide by a, so that's nice. Okay, so we move our 45 out of the way. In fact, I would say this would be a good time to maybe pause, try this one out. It's very similar to our first two examples, and see if you get the same answer. So pause now, and then when you unpause, I will have the answer up. All right, so how'd you do? Did you get 5 plus or minus 2i square root of 5? If so, that's pretty awesome, because one, you had to take out an I for your negative sign in your radical here, and then simplify, of course, like we had practiced in our previous sections. But yes, you should have gotten the value that squares or creates a perfect square on both sides is 25. Notice that again, when we did half of b way back here, this value, that's a terrible arrow because I used my mouse. But that is what ends up being the value in our perfect square. It is x minus 5 times itself twice. So you can kind of, if you want, use that as a little bit of a shortcut to kind of skip over this step. Whatever half of b is, it's going to be x plus or minus that number if it's positive or negative. That is the perfect square that you're going to create, and that is always true, which is good because it's going to help us with some of these ugly fraction ones that we're about to see. All right, these would be ones that are probably completing the square is not the best idea. And as we'll see later on, this is probably some quadratic formula candidates here. But let's go ahead and show that, of course, these can be done by completing the square. That's where quadratic formula comes from. So we are going to run into some fractions here, and one of the things you might see why, we don't have to divide by a in this one, but when we go to do half of b, not a nice even number, it's not going to divide in half nicely. So it's kind of a hint that completing the square is not going to be quite as elegant in this problem. So all right, let's power through it. X squared plus 7x plus blank equals negative 14 plus blank. Okay, now we need to figure out, of course, the value that completes our square. So this time, because our b value is still an integer, we don't need to use that half version that we saw back in the earlier part. But we're going to divide it by 2, half of b squared. Now in this case, I'm not going to go to a decimal. Don't go to a decimal. Keep stuff as nice fractions here. 7 halves squared, 7 halves times 7 halves is 49 fourths. Think again, top times top, bottom times bottom there. So we need to add 49 fourths to both sides. And you're probably thinking, yeah, Mr. P, I don't know how on earth am I going to factor this thing as a perfect square? I mean, what do I do with that fraction at the end? Seems impossible. And this is where I'd say, if we were to go back and look at the beginning, and I said, hey, it always factors as x, technically plus or minus, half of b before we squared it. So check that out. That's going to help us out here a lot. So we can actually write this as, here is half of b before we squared it. It's x plus 7 halves quantity squared. That is actually the perfect square we just created on that left-hand side. Now over here, a little unfortunate, we have some fraction work to do. I need to add things that, where 1 is a fraction. So we need a common denominator. So maybe we multiply this by 4, top and bottom. So let's see what that would give us. We'd get 40 and 16, negative 56 fourths. So 6 plus 49 fourths. Now we can go ahead and combine those. That should give me negative 7 fourths. All right, a little bit of ugly fraction where we had to find a common denominator, which was 4. Wasn't too bad. Multiply top and bottom by 4. And then combine our numerators, right? Keep the denominator. Now, we've got our perfect square. We need to square root both sides. Square root both sides. We're going to get x plus 7 halves equals plus or minus, and here's where those properties of radicals I showed you before. I said you can combine or separate them with multiplication or division. So check this out. Square root of the top, square root of the bottom. Here's why that's nice. Square root of the bottom is going to give us a nice whole number. Beautiful. So now we have a 2 in the bottom. Up top, we need to take out an I. So we have root 7 there. Plus or minus. And of course, we need to move this 7 halves over to finish this thing. So let's subtract our 7 halves over. Remember, that needs to stay in front of the plus or minus. So put it in front of it. And we should end up with something that looks like this. X equals negative 7 halves, plus or minus, I root 7 all over 2. Now, an alternate way to write this is, and this is fine, you could write this as your answer and box it in, and I would take that. It's not incorrect. But they do have a common denominator, right? I mean, you could even write this as something like negative 7 plus or minus I root 7 all over 2. And I don't know, that might look like some sort of formula we may have mentioned here. beforehand and quite a bit get answers that look like that from the formula. Anyway, just to show that's where we also get those answers. This would be like a quadratic formula, was probably a faster method one. And example 4, yeah, I don't think this is factorable. We're even going to have to divide by this a this time. This would definitely be quadratic formula would be the fastest way. But again, we're practicing this method. We're in honors. Let's give it our best here. So the first thing you do is divide everything by a. Okay, and you do have to do that to everything on both sides. I know our 0 is technically gonna 0 divided by anything is 0, but you know, we want to show we're doing the correct work here. All right, we divided everything by 2. Now we need to move, and I forgot my x here. Now I need to move our 1/2 to the other side. So subtract your 1/2 over. Set up our blanks on each side. X squared plus 5/2 x plus blank equals -1/2 plus blank. All right, I know this is it. Just looking over, we're starting with a fraction this time. And this is where I said, instead of doing half of b here, we can do it as 1/2 times b. That was the same thing as half of b, or b divided by 2. So this time we're going to take 5/2 and multiply it by 1/2. Just going to make the math easier when b is a fraction. This is still getting our half value and squaring it. So top times top, bottom times bottom, we get 5/4. And when we square that, same idea, top times top, bottom times bottom, we get 25/16. Oof, look at these fractions. 25/16 is what I need to add to both sides to complete my square. But we know our hack from earlier. We know what this perfect square is going to be. It's going to be half of b before we squared it. It's going to be positive 5/4. So this is the thing times itself twice that would give me this value, okay, which is pretty cool, the perfect square. Now over here, when we go to combine some stuff, we're going to need some like terms. Common denominators, not like terms. So 16 is probably a good place to make these two meet. So let's multiply that one top and bottom by 8. That gives me -8/16 plus our 25/16. Now we can combine those numerators, which gives us 17/16. Okay, all right. Getting most of our fraction work out of the way. Now we need to do the square root of both sides. And that is not the correct color. There we are. The square root of both sides. Beautiful. X plus 5/4 equals plus or minus. That's a terrible plus or minus. Plus or minus the square root of 17/16. But we know we can separate the top and the bottom as individual roots. And that's nice because the square root of 16. And what in the world happened back here? Hang on, let me fix this. Sorry, I had just noticed that apparently I wrote a 5 under this, and it's supposed to be a 4. So sorry, that's what I had to stop and get the eraser for. Okay, so this is root 17 over root 16. Apologies, thank goodness this was 4. So the nice thing is we are going to get a common denominator here. The square root of 16 on this side is 4. And the square root of 17 cannot be simplified. So the last thing to do here is to move this positive 5/4 over. So subtract 5/4 from both sides. Minus 5/4, minus 5/4. Remember to put that in front of the plus or minus, and man, we are running out of room. We get x equals -5/4 plus or minus the square root of 17/4. And you know what? If you wrote it like that, that's fine. Or, because they're both over 4, you could write it as like -5 plus or minus the square root of 17 all over 4, like a certain formula. So you can start to see with these problems that quadratic formula, kind of where it comes from and why these answers look like that. Anyway, we will derive this next lesson. We have one more part to get to, which is putting things in vertex form using completing the square. All right, so now I'm going to show you, this is the algebraic way of putting something into vertex form when we have something in kind of standard form of a graph, right? Like how can I go from one form to the other? Well, we know how to kind of get from this form to standard form. You need to take this thing times itself twice, distribute your a, and then add k to your other constant, and you can get our nice form. But how do I go from this guy to vertex form? That's what we're going to show you here. And it involves creating a perfect square. So it sounds like a job for completing the square. All right, let's do that. There's a couple ways of doing this. I know some people with their y's like to keep everything on one side. I like to move it over. So this is a Mr. Phillips preference. So we don't need to divide everything by a, and in fact, we wouldn't do that at the start here anyway. What we are going to do, though, is move our constant over. Y minus 7. Okay, this time there is a y, or variable, on this side. And I know we're going to set up our blanks in a second, so I'm just going to go ahead and give myself some space there. We have x squared minus 2x plus blank. Okay, so where that 7 was, right, we added our blank. So we are going to complete our square like we did before. This is my b value, so we need to do half of b. This time I'm going to write it above. Half of b squared, which is negative 1 squared, or positive 1. So we need to add 1 to both sides to make this factor as a perfect square. Well, this side, you could think of it, the two numbers that multiply to positive 1 and add up to negative 2 are negative 1 and negative 1. So you could write it out like that. But of course, we're after the perfect square. You could even, again, use your shortcut here that says half of b before you square it. Negative 1 is what ends up inside our perfect square. X minus 1 squared. On this side, combining my constants here, we get negative 6. And believe it or not, we are super close to our vertex form. All I got to do is pop this 6 on at the end over here, and we get y equals x minus 1 squared plus 6. And that guy is in vertex form. Beautiful. Okay, we're going to try one over here where, dang it, look at that, 5. We're not going to be able to take half of it and get a nice value. It's going to be a little bit ugly, but it's all right. Let's suffer through some fraction work here. So the first thing we need to move, again, is this 3 to the other side with y. And we're going to leave ourselves some room with our plus blanks on each side. X squared minus 5x. It's a terrible 5. 5x plus blank. Still bad, but we're going to roll with it. Okay, then I need to do half of b, and this is my b value, negative 5. So half of that, negative 5 over 2, that's half of b squared, gives me 25 fourths. Top times top, bottom times bottom there. Positive 25 fourths is what we need to add to both sides. Okay, now on the right-hand side, we already know what the perfect square is going to be. We're going to use our hack. Half of b before we squared it. So minus 5 halves. That's what our perfect squared is going to look like. On this side, we need to find a common denominator to combine our 3 and 25 fourths, or negative 3 and 25 fourths. So let's use 4. So we're going to go ahead and multiply that top and bottom by 4. So that gives me, oops, didn't change colors for me, y minus 12 fourths plus 25 fourths. Combining those, we get y plus 13 fourths. And we are almost done. All we need to do is pop that 13 fourths on the other side by subtracting it over. So minus 13 fourths. And we should have our final answer there. Y equals x minus 5 halves, quantity squared, minus 13 fourths. Beautiful. And that is in vertex form. We could identify our vertex from here. That rectangle isn't the best. Okay, where if we were identifying our two vertices from these previous two problems, this would be, so that is a rectangle. This one would be located at, hopefully, positive 1, positive 6. And our vertex here would have been located at positive 5 halves, or 2.5, and negative 13 fourths, which would be negative 3 1/4. Okay, so as a decimal, 2.5 and negative 3.25, something like that. All right, we got a couple more examples. Okay, well, I wrote over one of them a little bit, but I think we can see it enough that we're all right. Okay, these are the ones. How do I get to vertex form when there is an A value in front? Okay, these ones are tougher. And to be honest, if I asked you to change something into vertex form, if you tried to find a shortcut like opposite of b over 2a to get the x coordinate and plug in to get the y coordinate to find h and k, I mean, then you'd know h and k, and you could just steal the a that's this a, and then you could just write vertex form. So you could, anyway, you kind of cheated. But let's do the full mathematical way, because if you do conic sections in pre-calculus or later on in math, you will need to complete the square when there's numbers in front. So let's talk about how to deal with that. So again, I like to move this term over first, 50. Subtract 50, y minus 50, plus, I'm going to leave a little extra room in front of my blank, you'll see why in a second, equals 3x squared minus 24x. Okay, now what we're going to do is factor out or divide out a. Whoops, I didn't even really need my blank in that step, so apologies there. You can ignore the blank on the left right now. What we need to do is we're going to divide a, or factor out a, from both of the terms on the left. So it doesn't matter if it goes in perfectly. We're dividing each of them by 3 no matter what. Even if this didn't divide nicely by 3, make it a fraction. But we're dividing both by 3. So that leaves me with x squared minus 8x. And what we need to do is we're going to complete the square for what's inside of our parentheses here. So that 3, we kind of taken our a out. Okay, and we need to complete the square. Let's just focus on the right side for right now. We'll come back and talk about the left-hand side. But let's find the value that I would need to complete my square. So we'd look at, this is my new b value as we're completing the square. So I need to do half of that squared, which is negative 4 squared, which is 16. Okay, so we need to add 16 inside of our parentheses. Now, back over here, we need to be careful. I don't want to just add 16 over here because that's not really what I added to the left side or the right side of my equation. We put 16 in the blank, but we really added a value of 3 times 16. Think about, right, if you were to redistribute your 3, that's not just 16, it's 3 times 16, or 48. So we really need to add 48 into our blank here. And again, where that comes from is it's the 3 times our 16. Okay, but that's what we need to keep our equation balanced. Now, when we simplify on the left, we end up getting minus 2, so that's relatively nice. Inside my parentheses, this does factor as our perfect square. Remember, half of b, so negative 4, x minus 4, quantity squared. Lastly, we're going to add our 2 to the other side, and we have our vertex form. And it's not quite as bad as it first seemed, but certainly not quite as easy as some of our other cases. Okay, so there is our parabola in vertex form, where its vertex would be located at positive 4 and positive 2. Vertex at 4, 2. And an a value of 3, so it's opening up and it's vertically stretched by a factor of 3. Okay, let's try to struggle through this last one here. Last one, I mean, I purposely picked something that's pretty terrible, so hopefully you won't see anything worse than this. And I apologize, I know this video is long. Last one, subtract 13. Y minus 13. And we'll leave some room. We'll come back and talk about our blank there. Equals 2x squared minus 11x. And here's where I said no matter what our a value is, we're going to divide a out of both of these. So we're going to factor out a, or divide a out of both. That gives me negative 11 halves x plus blank. Okay, well, let's focus on completing our square over there. Half of b, guess we'll do green because it didn't change colors for me. So half of this, let's do times half since it's a fraction, right? squared. That gives me negative 11 fourths. It's an 11 in there, squared, which is 121 sixteenths. 121 sixteenths. Beautiful. Okay, so that's what I added over here, but I really didn't add just that. Remember, I did 2 times that, which is 242 sixteenths. 242 sixteenths. Well, goodness gracious. This is why you should check your numbers before you do an example in your video. All right, that's okay. Let's, well, I just need to multiply this by 16. So yeah, negative 13 times 16. You guys all have that one memorized, right? Totally not going to pause the video and use a calculator here. Okay, 13 and 16 is 208. I don't know, I guess pausing the video didn't work there. 208, negative 208 sixteenths plus 242 sixteenths equals 2 times, and at least we know that's a perfect square. And here is our half of b before we squared it. So x minus 11 fourths squared. Combine these things with our common denominators over here. It gives me positive 24, I think. Positive 34 sixteenths. Oops. So, oh my gosh, my equal sign's in the wrong spot. Ignore this, apologize. That should not be an equal sign there. So y plus 34 sixteenths. There we go, equals 2 times this. And we just got to move that 34 sixteenths over. That's 11 fourths. Oh, my writing's really gone out the window here, guys. Subtract 34 sixteenths over. I'm running out of room, so imagine that in your head. We're subtracting it over, and then you're going to see it over here as minus 34 sixteenths. Whew! Wow, okay, that one was pretty tough. This is like the worst case scenario for finding a vertex form. We saw some of the earlier ones as kind of worst case scenario for finding or solving with completing the square. Now, again, completing the square is not the ideal way to solve all quadratics, but it does always work. But so does quadratic formula, but like completing the square, quadratic formula and completing the square should really only be used kind of as last resort if we can't factor or solve quickly with square roots to begin with.